SwayamPrabha. Digital India. Educated India.
So, welcome back. We will continue our discussion on alternative and greener materials to plastic, which we started looking at in this particular week. So, this is the third video for the week 7, and in this video we will continue what we were doing in the previous video as well, looking at the greener plastic products. So, these plastic products mostly bio based, and you saw some examples earlier. So, let us look at some more examples now. One of the things we are looking at towards the end of the last video was plastic products or replacement for plastic products from using the raw material of bagasse, which is essentially coming from sugarcane. Sugarcane, India is we do produce quite a bit of sugarcane in India. There are several other countries like Brazil, Vietnam, China or Thailand. They also have a lot of sugarcane industry. So, in these countries there have been some push in terms of using this bagasse, which is essentially a waste product, and try to make a single use material, which is a plastic which we use for plastic, those plastic plates, plastic cutleries. So, replace those with material with plates made from bagasse, and this is and these are environmental friendly because they are biodegradable, so it can degrade. So, when we say environmental friendly, we need to also try to quantify that environmental friendliness, and we will talk about that in terms of later in this particular week. So, what is bagasse? This is essentially coming from the sugarcane. It is a residual fiber. Once the sugarcane juice has been used up, so it is used for so it is once the sugarcane juice has been used up, so it's whatever is the left product, it's around 40 to 60% of cellulose, 20 to 30% of hemicellulose, and about 20% of lignin. So, we have 20% lignin, 40 to 60% cellulose, 20 to 20% hemicellulose. So, that is what we are looking at. And of course, it will be found in countries that produces a particularly high amount of sugar, which does include India as well. And it is called a byproduct, but many people see it as a waste product because in the past it was mainly used as a fuel for the production plants, and that was also many places it is just dumped into the atmosphere rather than being beneficially reused. So, this kind of helps in terms of the use of this material for making a alternative to plastic, and which essentially coming out to be environmental friendly. So, it is a byproduct of sugar production, does not require additional cultivation area. So, it is unlike other biofuels and bio based resource, where if you are producing those resources, so you are changing the land use. Here you are not changing the land use, you are producing sugarcane and you are producing sugar or other products from the sugarcane, but whatever is the residual, you are trying to use it for this like a single use replacement for single use plastic products. So, its production, it is also used for building materials, packaging materials, disposable tableware. The paper industry is replacing wood fiber with sugarcane fiber to produce napkins, toilet papers and cardboard. So, that is also happening. So, since there is no additional cultivation area required, so we are not impacting any land use changes. So, we are not impacting any forest. So, that is the benefit of going for this particular raw material coming from sugarcane. So, it's they have been found to be stronger than plastic. So, that is also a good kind of things to know, because in terms of if you look at many startups are finding alternatives. So, this bagasse, the fibrous remains left behind after extracting sugarcane juice, can be used to make disposable cutleries and containers. There is a company called Papco, which you see all these product over here, and this product has been found to be even stronger than plastic in many cases. So, that is really encouraging finding, because we can use this product, we can use this waste material and make single used disposable cutleries and containers, which is essentially biodegradable. Of course, we need to manage these waste as well properly once they are discarded, but whenever this product is discarded, that needs to be managed properly, because when anything biodegradable means it has the it will have methane potential. Methane is a greenhouse gas. So, we need to make sure it is managed properly, the gas is collected, we are not contributing to climate change. So, it is not that we are solving one problem, but we are creating the other problem. So, that is always should looked into, and we will talk about some of those discussion later in this class as well. So, how they are made? It is from a steam boiler, air compressor, you will have sugarcane pulp, and that goes to hydraulic pulping, pulp mixing, forming machine, shaping machine, edge cutting, UV sterilization. Then you have the final product, which is used for making those single use containers. So, in terms of their steps, if you look at one by one, we start from pulping. Pulping, as you know, pulping is also done for paper. Pulping, which you are is soaping the pulp paper board and put it into hydraulic pulper. So, that is what it is all about. So, here rather than using like fibers from trees, we have the fibers coming from this sugarcane. So, it will be put into the hydraulic pulper. After pulping, the pulp will go into the mixture tank, where all water and oil additives are added. Then it goes to the pulp supply tub for forming machine, vacuum dewatering and forming. So, that is the next step. So, in forming is one of the key process in the production line. Its process is quantitative pulp supply, and then you have vacuum dewatering with advanced technology to eliminate holes, uneven thickness during production. So, the semi finished product move to the drying mold for solidity. So, you have pulping, then forming, as you saw in the previous slide in terms of the layout of the process. So, very similar to what kind of you see for any paper based product as well. Then there is a shaping and drying, which steam is used for heat drying, and 70% if you use heat drying compared to electrical energy, you are saving 70% of the energy will be saved, meeting the hygiene requirement for food packaging. So, qualified production rate is up to 99%. So, that is it's used in the, then we have after shaping and drying, it has to be cut and sterilized, because as you know, it will be used for food usage. So, it has to be really free from any pathogens, bacteria. So, product taken out from shaper will be moved to edge cutting machine, where the extra edge is trimmed. UV sterilization is applied to make sure production meets a hygiene requirement, and then finally product is packed and stored. So, that is how and it is not, say if you look at that, it is nothing anything spatial over here. It is only that rather than using the fibers from other sources, now we are focusing using the fibers from the sugarcane waste, which is also called bagasse. So, we are taking from the bagasse, we are extracting those fibers and using it for making this product. And since it is coming from a material like a bio based material, it is a biodegradable material, and it can be used for those like for after its end of life, potentially can be used for energy generation as well. So, it is either as bio based energy, or it can be used for thermal energy too. So, thermal waste to energy plants can use it as well, because since these will have relatively higher calorific value as well, as long as it is kept dry. So, spatial characteristics, they are very stable, they are sturdy, they are not very flexible though. So, it is you cannot give a lot of shapes to it, but it is stable, it is sturdy, and it has good thermal property, and it can withstand the temperature of minus 25 to 220 degrees centigrade. So, which is kind of much beyond what a typical temperature range will be for human settlement. So, even for very cold climate, inside temperature is less than above minus 25. Outside it may be less, but that's only for few days, few weeks maybe in the year, but even in those weathers, since the temperature is controlled and you are pretty much above 0 degree centigrade all the time. So then you have it is a water repellent, it's a grease proof, it's suitable for hot and very oil and greasy dishes. It's completely biodegradable and compostable. So that really helps in terms of going for the greener alternatives, as we said in the beginning of this particular video, that in this particular module, the focus will be looking at the greener alternatives to plastic, and this could be one alternative to plastic. So many of these initially are costly, as I said I think in the previous video as well. It starts with costly, but as the market picks up, so that's why in my view, although many people may not agree with me, but in my personal opinion, the government should help these kind of industries, and that's what I have seen it happening in the Western world. Although Western world, we say they are the capitalist society, they are not socialist, but many times I feel the way the policies are being done even in US or in Australia or New Zealand or Canada, for example, I found them to be since I've stayed there for quite some time, so I have followed their policies a bit as well. So I found them to be kind of more socialist today than what we are in India in many cases. So especially from when we have our interaction with the industry. So industry many times need little bit of hand holding by the government. And when I say hand holding, it is to provide them with required support so that they can withstand, especially the initial hiccups. Because say for example, this if I set up a company, or if you set up a company using this bagasse product, initially, since you will have a lot of infrastructure to be in place, there are a lot of research involved in it to come up with all these products. So the cost of this will most likely be higher, sometimes much substantially higher than the plastic product which it is planning to replace. So there the government role needs to come in play, where government needs to kind of incentivize some ways to consumer to buy this product, and at the same time give subsidy to this company so that the products are at cheaper, relatively a competitive price should be there. So, and that could be in the form of tax credit, providing land, or giving some electricity bill rebate or whatever, but there has to be some sort of mechanism, and the Western world has a lot of mechanisms like that. So, and they also fund research, like for example, in US they have a concept called Small Business Innovative Research, and that SBIR, it's a short form is SBIR, and that's the industry can put $1 and the research funder they put $3 up there. So it's a kind of in $25,000 you can have a $100,000 project, and that has to be totally focused on industry, something which improves the industrial process, something which improves the job prospect. So you can create more jobs. So it has to be totally applied, not basic, but at the same time you will get some things coming out of that. In Indian context, unfortunately, still we are so much stuck in that whenever you go for any funding, they will say, oh, where is the science here? See, science is already there, but it's the application. As an engineer, we have to also look at the application. We should focus, we should move beyond that. We need basic science research, I'm not doubting that, but we also need a lot of applied research, and it's not only the consulting part, it's the research funding also needs to be there, because sometimes consulting does not really help, because consulting requires quick solution, and where many times this kind of work takes time. So it's a bit more like a research funding rather than a consulting funding. So that was a bit sidetracked, but just wanted to talk about that, because to put things in perspective. So if you look at some of the products coming out of it, lots of containers, different types of containers can be made from bagasse products, as you can see. Then there are some others products are also out there. This one is seaweed based water pouch, where the water will be in the pouch, and you can it's kind of a bubble design. It looks like a water bubble. So, it's plastic bottles. Why the plastic bottles are being used? Because it's easy to transport water in there, but of course, it takes energy to make those bottles, and when you are done with the drink, it takes more energy to unmake the bottles, like to treat those plastic waste. So, as plastics won't fully degrade on their own, now there is some startups coming up where they say let us skip the plastic bottles entirely. It's called it has made a capsule called OHO for transporting water that is not only biodegradable, it's eatable. So, you can eat that. OHO is a bubble design by skipping rock slab that enriches drinking water with an edible membrane made from a natural seaweed extract. So, you have a natural seaweed extract, and if you do not feel like eating it, the flexible bubble like packaging biodegrades in just 4 to 6 weeks. So, even if you put it in a biodegradable container for composting or aerobic digestion, it will go there, and the membrane can be flavored or colored. It can also be used for other liquids such as soft drinks, spirits or cosmetics. So, there are a lot of other applications are also there. So, this is the goal for these kind of thing is that will eliminate the plastic bottle. So, this is kind of alternative to plastic. You can consume it but at the same but if you do not want to, you can put it in your wet waste container as well, because this can be composted or anaerobic digested. So, there are a lot of examples are there. We have picked few which we thought is more kind of relevant and kind of making a lot of news, a lot of attention, but there are several others out there as well, which I would strongly encourage you to look at those. We are also putting up some other examples as a online reading material, but so as I said, other than these slides, you will have some more reading materials to look at. But make sure you also look at some of this Google search, do some Google searches, do some YouTube searches, and look for alternatives, and you will find some cool stuff. If you really feel something is really kind of interesting, cool, and a lot of promising, put that link in the discussion forum, and it will help all of us, including me, to learn about that. So, this in terms of production of OHO, how it is done, you have dissolve sodium alginate in water. So, you take sodium alginate, dissolve it in water, dissolve calcium lactate in a separate bowl, transfer them together in a bath, in a sodium alginate to calcium lactate bath. You mix the solution and transfer water balls to water bowl. So, you just make it in a water bowl, and then you fill water in there. So, that's another that's one how it is done. So, it's not that like this doesn't seems to be too technical, too difficult to do that, and this already you see it at least for a trial basis, it is already out there. Now, there is another alternatives, like we use lot of containers at our homes from which is made out of plastic, whether you are talking about your shower dispenser. So, rather than using soaps like a solid soap, these days there is also a concept of using liquid soap, like your body wash or shampoos and other stuff. And of course, shampoo is always a liquid, but body wash is we used to use like a different type of soap. But these days there are liquid soaps available. If you go to many hotels, you see that the liquid soaps are there, and then liquid soaps are also coming with a dispenser now. So, that becomes a little bit easier reduces the wastage, and those dispensers, very similar to what you see over here, is mostly made of plastic. So, but there are alternatives coming in terms of safe paper bottle. So, first ever shower shape paper bottle is in the market. So, L'Oreal they have launched an eco beauty range, seed phytonutrients. The product themselves sounds lovely, made from 93 to 100% natural ingredients, cruelty free, paraben free, etc., but the packaging is where the real innovation is. So, made by Ecologic, that is the outer card is recycled, recyclable, compostable, glue free and water resistant. The inner liner is made with recyclable plastic and uses 65% less material than regular plastic bottle. So, we cannot really able to eliminate the 100% plastic, because since the inner layer where you will have the contact of liquid with the surface, if you have just the pure paper, the paper will you will have paper will get soggy, its structural integrity will get compromised in contact with water, but that is why we need a liner. And that liner is there in many places, even the coffee cups. Say if you go to Nescafe and other places, when you take the coffee and you take it in a paper cup, it is not 100% paper. There is a liner of plastic in there as well inside, so that you can hold on to liquid there. Otherwise, you will not be able to hold on to liquid, because liquid will make your like a cup not usable, make it soggy, its strength will go, and you will lose your coffee or tea in between while you are consuming it. So, that is not going to work. So, that is why we have a liner, like a thin liner of plastic there. Okay. And there are some paper bottle, like again the paper bottle, that is the same thing. It will be paper bottle by Ecologic brand, and they are popular in number of categories, can be used for wine, pet food, protein powders, laundry detergent, to name a few. It consists of molded paper pulp outer shell made from recycled, corrugated and old newspaper that can be recycled up to 7 times. The inner film, which is the polyethylene pouch with a spout, has been until now the inner component comes with it's a plastic, and inner component that comes in contact with the product with a liquid powder or other. When compared with a rigid plastic container, the pouch reduces plastic use dramatically. So, we are making some effort, we are making some benefit, but it is still not 100% plastic free. And because the this cells which are there can be nested, the pouch can be transported flat to an end user. So, you can so even the transportation cost can go down. So, one truckload of packaging material equals 9 truckload of rigid plastic container. So, you are reducing the transportation cost. So, in terms of inner pouch, what they are trying to put a very thin extrusion blow molded liner that is fully recyclable, made of 80% post consumer HDPE, requires 60% less plastic than traditional shampoo bottle. And then they do not have the side flange, there is the elimination of glue, interlocking patterns to bind the two cells together, and that's again helps in terms of coming up with an environmental friendly material. So, there are a lot of I would say lot of innovations coming into this area, where you see that many newer products are coming out, many greener products are coming out. Another example, this is a stone paper and plastic. This is Etiketten Bakers stone paper, consists of 80% limestone and 20% recycled polyethylene. This combination makes a 100% ecological product that can be used for several purposes, from posters, flyers and to bags, hang labels, pot covers. It is a substitute for polypropylene, that is what because it is a water, UV and tear, more than paper resistance. On top of that, it is also writable. So, even when it is wet, so you can write on it. The paper can be printed with thickness between 100 and 400 microns. So, you can have different quality paper as well. So, that is because of this issues related to plastics. So, initially what happened? So, if you look at the industry, the way it has evolved, initially we moved pretty much many products from non-plastic to plastic. We started using plastic for those products. Then we realized that plastic is actually not good in terms of long term environmental issues. It does not degrade, it chokes our stormwater system, it is floating on many of the surface water, and also it is getting into the sea, impacting our sea life, impacting several species. So, then we realized that this is not the way to go. So, we made a mistake by using plastic very like I would say in a huge way. Probably the use of plastic, I think it is the most kind of, you can say that from an economical point of view, plastic has done phenomenal over last 3, 4, 5 decades. but from an environmental point of view, as more and more plastic waste is coming into the ocean, the issues are becoming more and more grimmer, more and more challenging to handle those. So, there is so that is the reason why there is a push to look for greener material, better alternatives in terms of environmental performance. So, that is what we are talking about in this particular video. So, for the stone paper, how they are made, it's environmental friendly. Entire production is from cradle to cradle principle. In contrast, now what is to cradle? Earlier you may have heard we talk about cradle to grave or cradle to gate. Cradle to grave is when you start for any product from the very beginning to all the way to the end. That is your cradle to grave. Cradle to gate is many times the companies will make an argument that I do have no control on how my product is being used after a product is being used or disposed after I have sold it. So, I do not have control on that part. So, that becomes cradle to gate. So, we have to stop the LCA right there, which is a calculation to find out what is the environmental footprint. So, and then the third option when many times people talk about is gate to gate as well. So, within the process, if you have certain modification, that becomes gate to gate. The other things before and after, upstream and downstream, remains the same. So, in terms of now cradle to cradle is where you are talking about the recycling, reusing and bringing that material back into the chain. So, that becomes your cradle to cradle. So, that is the whole concept of this circular economy, which we will talk about in the next video, in next week's video. So, cradle to cradle, there is even a book titled Cradle to Cradle, which talks about all these basic principles, which came I think in late 90s when the book was first published. Now, this concept has become very popular, and you see many documents, many reports, many writings done on circular economy and cradle to cradle concept. So, if you look at the production of regular paper, production of stone paper does not require water, cellulose, acid or bleach. So, that no cellulose means no cutting of trees. CO2 emissions are 67% lower in production of stone paper than in production of cellulose paper. So, there are so you can see the benefit which is coming out of it with all the innovation that is coming into the picture. So, these are some of the application of stone paper products, pretty much all the things that you can do from a paper product, different type of containers, straws, plates, cups and all that, which is we kind of need for for our usage in different usage in homes and even as a community level. So, that is on the stone paper part, which is essentially focused on plastic as well as paper. Next we have is palm leaf product, which could be a perfect alternative to plastic as well. So, there is another company called BioPack, which is environmental packaging specialist. They were looking at they increases the range of palm leaf products and this offers a 10% discount. This range is aimed at the street food retailers who are looking for something a bit different. So, here the Mark Brigden, who is a technical director at BioPack, said our palm leaf products are suitable for most food, both hot and cold. So, you can use it for food. They use for many mobile caterers and street food traders who are looking for a bit different packaging. The fact that they are eco friendly and compost inlet and in around 12 weeks time also reduces the level of impact. So, it's palm leaves seeds, which is a BioPack uses for the production, provide valuable employment for a small village community and their harvesting. So, we are looking. So, there are variety of alternative sources which are being looked into once we saw all the issues of plastic waste management. So, you can say from the palm leaf you can make different containers, as you can see over here on our right on top, and that's kind of gives like a newer type of material coming out, which we can use to not replace the plastic. So, that will help in replacing the plastic. So, in terms of alternatives of palm leaves, there were two young women from Berlin. They have developed an interesting alternative that can be easily thrown onto compost after sopping and can be used in an alternative way. The two students came up with leaves of an Erica plum, and which is grown on plantains. So, as you can see, there are different types of plates, spoons, forks, and some other bowl containers, and all that is also there. So, let us stop here, and then we will continue on our discussion on this looking at greener material, and towards the end of the video this week we will also look at the impact, how to calculate the impact. So, when we talk about we are lessening the environmental impact, how can we quantify that? We will have a quick discussion on that as well. So, with this we are finished the third video of week 7. Again, as usual, I keep on reminding you, go over the lecture material in time, make sure you do your quizzes on time, because you should take in fact all the quiz, although I think you are allowed to miss maybe one, or maybe I do not remember right now, but you are allowed to miss maybe 1 or 2 quiz because it says based off certain number. But again, more you take, better it is. It gives you good practice, and if you should, those of you who have registered for the exam, again all the best, and I hope that all of you should have registered for the exam, because it would be interesting. Once you have registered, you should take the exam and get the certificate, because otherwise putting all these effort and not getting the certificate does not really make sense. Okay, so let us close this video here, and we will continue our discussion from this point in the next video. Thank you.